This review is on systems of equations. A system of equations is anytime you have two or more lines. Typically, it's two lines for what we work with. The solution to the system is the point where the lines intersect, or another way to think of it is the points that make both equations true. There are three possible solutions for a system of equations. One is that the lines could cross at 2 points, so they might look like this. And then this point right here would be your intersection, and it would be a coordinate x, y. Another option is the lines end up being parallel, which if lines are parallel, that means they're going to have the same slope. And by the definition of parallel lines, that means they're never going to cross, they're never going to intersect, which means there's no solution. The third option is the lines end up being the same line. So you end up getting one, and when you graph the second one, it ends up being the same line, or going right on top of each other. Because they're right on top of each other, when you're looking for the intersection is going to be infinity because there are infinite number of solutions or infinite number of times where these lines cross because they're laying right on top of each other. There are three methods that you can use to solve systems of equations. The first one is by graphing. When you're graphing lines, you always want to put them in slope-intercept form first, which we know is y equals mx plus b. So you're going to put your lines in that format, you're going to graph both lines on the same graph, and then you're going to find the intersection point. So let's do an example. If we were to take this first line and we want to put it into y equals mx plus b form, we need to, first I'm going to rewrite the equation. We're going to subtract the x from both sides, so we get negative y equals negative x plus 2. We're going to divide by the coefficient, which is negative 1. And so line number 1 is going to be y equals x minus 2. Then we're going to do our second one over here, which that's already in slope-intercept form. So our second line is y equals x minus 3. So let's graph the first one. For graphing, we start at our y-intercept, which is negative 2, and then we're going to go up one, right one, up one, right one, up one, right one. Of course, you want to use a ruler. It's a little bit harder for me to do on the screen here, but you're going to use a ruler and draw your line. You always want to label your lines. This is line number 1. I have different colors here, which makes it easier, but when you're doing it, you're going to have just your pencil or your pen, and so you need to make sure you label them. You can either do it by labeling the numbers like I did, or you could write the actual equations on there. The second line, the y-intercept is negative 3, but the slope is also 1 over 1. So up one, right one, up one, right one. Now, you might recognize right away that these are the same slope, which means they are in fact going to be parallel. Make sure you label like I said. So if they're parallel lines, that means by definition they're never going to cross. So the intersection or the solution for this system is that there's no solution, NS, because they're never actually going to cross. A second method is to solve by substitution. The goal of this method is to substitute in an equal value to create an equation with only one variable. You want to think about what the word substitution means in real life, like a substitute teacher, or you put in a sub in a soccer game or some sort of sporting event, and when you do a sub, something subs in for the exact same value. So when you are solving by substitution with equations, you're going to pick an equation and you need to get one variable alone, or you're going to solve for that variable. You could always fall back on putting them both in slope-intercept form, but if there's an easier way, you're going to want to go for it. So for this problem, we want to look at both of our equations here, and we want to try to get one variable alone. Now I see in the second equation that the y already has a positive 1 of a coefficient right here, and so that would be really easy to get alone. So if we just add the x to both sides, we're going to get y equals x plus 2. So we already have one equation here. Now, we know that this is saying y is the same value as x plus 2. So what that means is we can substitute in anywhere we see y in the first equation, that x plus 2. So we're going to go ahead and do that. So we're going to have our negative 4x plus 2 times, you always want to use parentheses, and instead of writing y, we're going to write that x plus 2. So again, that's where all of these are the same. We're substituting x plus 2 in for y. At this point, we only have one variable left, and so that's an easy equation for us to solve. So we're going to go ahead and solve this equation. We're going to use distributive property, so we have negative 4x plus 2 times x is 2x, plus 2 times 2 is plus 4 equals 8. We're going to look for like terms. negative 4x plus 2x is negative 2x plus 4 equals 8. At this point, I'm going to draw my Grand Canyon line here to keep things even. I'm going to subtract the constant, the 4 on both sides. We're left with negative 2x equals 4. And then x is being multiplied by negative 2, so I'm going to divide by negative 2. So we end up with x equals negative 2. Now, we're not done yet because that's only half of our answer. Remember, when you have a solution, it's going to be a coordinate, right? An x comma y. That's going to be our answer. And so for now, we have x is negative 2, but that's only half the answer. To get the second half, we need to plug it back in. So we're going to take this negative 2, and we're going to make a second substitution. So I'm going to go back and do negative 4 times negative 2 plus 2y equals 8, and then solve. Negative 2 times negative 4 is positive 8 plus 2y equals 8. I'm going to subtract 8 from both sides. I'm running out of room here, but that's okay. 2y is equal to 0. If we were to divide by 2 on both sides, we would end up getting y is equal to 0. So that's the second half of our answer. So we're going to take that and put it in our final solution. So this system of equations intersects or crosses at the point negative 2, 0. The third method for solving systems is by elimination. The goal of elimination is to eliminate one variable by adding the two equations together. So at first you're going to stack the equations, which means get all your x's lined up, your y's lined up, and your constants on the other side. You're going to compare the coefficients of each variable in each equation. Your goal is to get opposite coefficients in one variable. So let's do this example as we're reading through these steps. So our equations are stacked. We've got our x's and our y's and our constants lined up. And we're going to look at the coefficients of the x's and the coefficients of the y's. First, let's look at our x's. We have a negative 4 and a negative 2. If we were to add those together right now, we would get a negative 6, which would not eliminate those. For the y's, we have an invisible 1 and then a positive 5, which again, if we added those together, we'd get a positive 6. So again, that's not going to eliminate. So the opposites do not exist, and so we need to look for a way to multiply one of the equations or both of the equations so that we can make the opposite coefficients. So I'm going to get rid of my highlighting here. So let's focus on the x's. On the first equation, we have negative 4x, and so we want to think, okay, what would be the opposite of that? Well, in negative 4, the opposite would be positive 4, and so is there something we could do to that negative 2 and multiply it by something to get it to be a positive 4? So if we multiply that equation by negative 2, the whole thing, then that would become a positive 4, and those would become opposite coefficients. So first we're going to rewrite our first equation because we're not multiplying that. We're going to leave it alone. And now we're going to go through and do this second equation. We're going to distribute that negative 2 out. So we get negative 2 times negative 2x is a positive 4x. We do negative 2 times positive 5y is negative 10y. And then negative 2 times positive 4 is negative 8. Now again, you could look at the y's, and the first equation has a 1y, and the second one has a 5y, so you could multiply the whole first equation by a negative 5 also, and you would get the same answer. We're just going to focus on the x's here, though. So now, if we were to add these two equations together, negative 4x plus 4x is 0, so those cancel out. Positive y minus 10y is negative 9y, and 8 plus negative 8 is 0. So now we're going to solve for y. Y is being multiplied by negative 9, so we're going to divide by negative 9, and we get y equals 0. So again, we're not done. That's only half of our answer. So we're going to take that y equals 0 and substitute it back in now to either equation, and we're going to solve for x. So I'm going to do the first equation. We're going to do negative 4x plus, and this is where we're putting that 0, instead of the y, equals 8, which is just negative 4x equals 8. And if we solved, we're going to divide by negative 4, we would get x is equal to negative 2. So our answer then is made up of both of these because we're looking for the point at which they intersect. And so you want to do an x comma y. So our x is negative 2 and our y is 0. So these lines, or this system of equations, the solution is negative 2 comma 0. One thing you want to be really careful about, and I kind of have this note here, is that if you multiply one side of your equation, you must do it to the other. And I kind of breezed over that while I was solving the problem. But right here, when you have this -2, you have to multiply it by each piece here to get the +4, the -10, and the -8. So make sure you do that by each term in the equation. Okay, so that's your review video on systems. Another big part of this, and I'm not going to do an example of this, but with systems is to be able to create equations and use those equations or that system to solve a word problem. One of the things you want to look for is if the word problem says create a system, that needs to be a red flag in your mind that you're creating two equations. And you always start with the let statement on those. Let x equal blah, 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 and let y equal blah, blah, blah. And that's how you're going to set up those equations. So again, system of equations, you've got two or more lines. The solution is you're looking for where they cross, and you can use either graphing, substitution, or elimination to solve for that.